This is my son playing with a wind tunnel at the museum a few weeks before Christmas. So I get a text from my wife asking if I can make one. And I said, yeah, I mean, how hard could it be? And this is version 2. Well, it's more like 2.1.4. So when I told my wife that I'd make this thing, I said, oh yeah, it won't be that bad. I mean, it's only just a fan and a tube. I mean, how hard could it be? A little bit of plywood, some threaded rod? No, it was a lot harder.
Don't wanna be where I am, and I want something more, take a chance. It could be possibly my last dance, my last dance. I don't wanna let myself down, myself down. I don't wanna let myself down, myself down.
Measure your materials. I did not measure the conduit before I started the design, and I just Googled what EMT conduit's supposed to be for 3/4. Turns out the internet lied. So I spent the better part of Christmas Eve hand sanding each one of these pieces to make it fit. So because I had to sand each one of the pieces, none of them fit on the conduit the same way, so they would get in a bind as they were working down the conduit, and every one of them snapped in some form or fashion. Now, it was like 7 hours until showtime on Christmas morning, so I didn't have time to make another one, so I just kind of let it go, and here's what happened. So the next problem that I had was, this was a component of version 1, and the fan would suck air from the bottom. Well, the scarves would fly up in the air and they'd fall down and then get sucked right back into the fan, and then the fan would just get clogged and not pull any air through and make a lot of noise. That was the worst problem, because that meant that either myself or my wife had to sit right beside the thing and pull scarves out all Christmas morning. So that design had to go. Even though this thing is pretty simple, being just a fan and a tube, it plays with some pretty cool physics. Let's talk about that. An object inside the tunnel is pretty much experiencing the same forces as if it were free falling in the sky: gravity and drag. They're fighting in kind of a tug of war of the acceleration of the falling object. The bigger or more projected surface area an object has, the more drag force is applied. Imagine the way a parachute works. By making the surface area bigger, the object slows down. Interestingly, the amount of drag force is roughly the square of the object's acceleration. This means that an object falls, and if its acceleration increases, the drag increases faster than the acceleration. So if an object is allowed to fall long enough, it will eventually stop accelerating. The term for this is called terminal velocity. If you place an object in our wind tunnel and it flies out the top, there's more drag. If you put it in the wind tunnel and it falls, then gravity is winning. There's not enough surface area. However, if it's kind of suspended in the tunnel and just kind of floating around, then you've kind of hit the terminal velocity for that object. A little bit of time has passed and I've had some time to make some revisions, so let's build it and hopefully this is the last time. Instead of the conduit going through the holes in each one of the support rings, it's now going to just have a small piece of conduit that is compressed by the all thread that's going to go through the whole thing. So it'll be much easier to assemble and a lot easier to make sure that each one of the support rings are parallel to each other. The bottom now has a stainless steel mesh to keep those pesky scarves out. The plastic tube is now held in place by these 3D printed clamps that distribute the clamping force and won't rip like the staples did. Don't use staples with a toddler. They'll put their hands through it. In case you're wondering, version 2, it was a big hit as well.